Hey everybody, my name's Jay Gordon. Hi Albina, how are you?
I'm doing great. Hi, Jay. I'm Albina from Microsoft Reactor.
Wonderful. And my name's Jay Gordon. I work on the Azure Cosmos DB team. I am always looking to meet our community and put developers first. And this session today is about putting developers first, helping them build data. And we're going to build data for their applications and how it can look in both a relational, non-relational way. But we'll be focusing mostly on relational today. So that being said, we've got a little bit of housekeeping that we're going to do before our guest joins us, and then we'll get into it. Albina, I know that you've got a little something to let our wonderful guests know about. You want to tell us quickly about our code of conduct?
Yes, of course. Before we begin, I'd like to quickly review two items with you. The first one is going to be our code of conduct. So please take a moment to review it. And Microsoft Reactor seeks to provide a respectful environment for both our presenters and our audience. So we do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, we have our event guidelines. So this session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. And I can share the link later with you guys so you can take a look and see where it's going to be located. But yeah, that's pretty much it, Jay.
Great. Thank you so much. And you know what's great is that I have the link to today's show. I'm just posting it in the chat now. You can go ahead, you can go to that link, and you can get all the show notes for today. There's a lot of great URLs that are going to point to documentation, ways to meet up online with our guest if you want to ask questions. Lots of great stuff. Now, I am going to quick do a little bit of housekeeping. I've got some things that I want to tell you about. One of the first things is I want you to know if you've got questions, leave them in the chat and we'll address them as soon as we can. Sound good, Albina? You think we've got time for some Q&A today?
Of course, I'm sure people are going to be very interested and curious, so let's bring them in.
Absolutely. And then another big thing we've got, and Albina, I'll see you again later on. Sound good?
Yes. Thank you.
Oh, sorry, Alina. I should have given you the whole chance to say thank you. Okay, so just so you all know, we've got our Azure Cosmos DB Conf that's coming up right here online. You can watch it streaming. It's going to be great. You can register today. And how can you register? Well, let me find my banner. There we are. You can go to, and you bear with me, I'm having some tech issues here. I'm to resolve. Sorry about it. Hi, I'm my best to hear them. Let me see if I can bring our guest in and see if we can get her. I apologize. This is kind of embarrassing, but you know, these things do happen. Okay, let's see. How are we doing now?
There we go. How's it going, Jay? How's it going, everyone? Good to see you today. So I know Jay was having some internet difficulties, so let me show you what he was trying to show you with Azure Cosmos DB Conf 2023. So that is coming up on March 28th. It is a virtual conference with all sorts of cool things coming from partners who are using Azure Cosmos DB, also details from the Azure Cosmos DB team, some cool things going back and forth. Check it out. If you go to learn.microsoft.com and look under events, that's where you will see Azure Cosmos DB Con coming up. And then
here's the URL right down there. Thank you so much, Sarah.
Check that out.
I really appreciate you covering for me. if any of you have ever had an automated process that runs on your computer, you will know sometimes it happens when you're not expecting it. This was one of those times. So thank you, everybody, for being patient. So we've got some great stuff to talk about today, Sarah. You have been one of our guests before. You are absolutely lovely to have on here. I am so thankful that you want to take part in all of these things. And we're going to talk a little bit more. But before we get into the big things for today, I want everyone to know what we're going to be talking about. And I've got a little something for you to watch to kind of just line up what Sarah's going to be talking to us about. All right. So we'll be right back.
To meet today's demanding expectations, apps need to be fast, available, and flexible. Designed for developers, Azure Cosmos DB is a stellar distributed database service. It's fully managed, fast, and offers the flexibility to build apps of any size or scale with relational or non-relational data. Let's say you want to build a multi-tenant SaaS application that needs full relational query and ACID compliance with the high performance of distributed data. Azure Cosmos DB for Postgres blends cloud-native performance and the highest level of compatibility with the Postgres ecosystem, plus high regional availability. Or maybe your e-commerce app needs to scale overnight to meet customer traffic spikes. Azure Cosmos DB for NoSQL, MongoDB, and Apache Cassandra delivers the low latency and high availability to satisfy demanding shoppers and keep up with growth. Whatever you're building, Azure Cosmos DB has the speed, scale, and SLA-backed high availability you need to deliver an always-on app that meets evolving standards. The free tier makes it easy to get started, develop, test your applications, or even run small production workloads for free. The app universe awaits. Take off with Azure Cosmos DB.
I love that. And I think it kind of lines up what we're going to be talking about today. So I would have liked to give you a much better introduction than I did as we started here. So I'm going to try it over again. Today, our guest is none other than Sarah Dutkiewicz, aka Saduki. Hi, so much thank yous for you showing up today.
Sure. Thank you for having me. I'm excited to share more about Azure Cosmos DB, and especially with one of my longtime loves, relational data. And on Valentine's Day of all days, you know?
Yes. Big hearts today.
Lots of hearts.
It is Valentine's Day. We've got an amazing presentation that you're going to be giving today that is full of love.
Lots of love. I always bring love to my presentations, though, not just Valentine's Day.
Yes, absolutely. Just so everybody knows, if you'd like to find Sarah on Twitter, you can go to @Saduki. You can also check out her LinkedIn. It's right there. And she's got a website. We all got websites, it seems. Going out too. I'll put all these in the chat, and everything is also in the YouTube video description. You can go there. I've put it already in the chat. If you need it again, let me know. So, Sarah, I know that we've got a limited amount of time, and I want you to be able to jump into it. So just so everybody knows, can we just give you a brief intro of like what you do nowadays, what your role is, and why you're so passionate about Cosmos?
So my role nowadays is I'm a general technology consultant. I do software development, I do software architecture, I do data architecture, I do database administration. I run the gamut on just about everything except that middle tier. When it comes to development stuff, I don't deal with the services and the event hubs and the service bus. I leave that to those who enjoy that. So I do really front end stuff, I do really back end stuff. Why am I so passionate about this? Data's been my career. I have another blog that I didn't send over. It's data-adventurer.com. So all about data, always have in my career, from Access in Excel to SQL Server and Azure Cosmos DB and MongoDB and all sorts of other platforms on top of that. MySQL and Postgres are some of my older databases that have been following me for most of my career. And so today I am super excited I get to show what happens when Azure Cosmos DB and Postgres come together. And I see we have some questions in the chat already. So rest assured, we'll be able to answer those. Like Jose's got a question about, is it stored in a document DB way? it's not JSON, it's tabular. I'll talk about that. And then there was another question from Anon OX1 about Cosmos DB only for users with massive amounts of data. Nope. My presentation talks about relational data at any scale. So just starting out all the way to, okay, now let's scale it up. And I'll point out some gotcha about that. But
So
yes,
why
Anon 0x1, elephant on the cloud.
Absolutely. So why don't we talk about them elephants? We're going to be talking a lot about Azure Cosmos DB for PostgreSQL, which is one of the latest and greatest offerings that we have here on the Azure Cosmos DB platform. What I'm going to do now, Sarah, is I'm going to bring up your presentation.
Sweet.
And then I'm going to give you some room to go ahead and start presenting.
Awesome.
Sound good?
Sounds good. Let's go. Alrighty. So leading up to this presentation, I was playing with Microsoft Designer, and I wanted to make sure that everybody knew with Cosmos DB that it's not just NoSQL. So I wrote a poem. Roses are red and violets are blue. It's not just NoSQL. We love relational data too. So happy Valentine's Day for our Cosmos friends. But today I am here to talk about relational data at any scale with Azure Cosmos DB for PostgreSQL. So quick backstory, when I was first introduced to Azure Cosmos DB, my mind immediately was like, okay, it's the flagship offering from Microsoft when it comes to NoSQL. If I hear NoSQL and I think Microsoft and Azure, I'm going straight to Azure Cosmos DB. So when I heard about this relational data stuff going to Azure Cosmos DB, I was like, wait, hold on, what? I come from a relational world. My poor head was exploding when I saw that my NoSQL solution is now supporting relational. How does that come to be? But it happened. And I started playing with it and went, oh, and I had a lot of aha moments too, because again, my relational mind, I understood how things worked. And so when I saw how it worked with Postgres, I'm like, okay. And then I put 2 and 2 together with the rest of the Azure Cosmos DB stack. So let's talk about this relational data at any scale. And as I promised my buddy Simon, there are hearts in the presentation. There's not many hearts, but there are hearts. So Azure Cosmos DB loves Postgres. So October of 2022 is when they announced that there was a new API. I like how Kiro Gavrila, how he puts it is, we had a new baby. He calls the APIs his children. This was a new baby. So yes, here's our new baby, Postgres API. Love the Postgres API. But I also know that not everybody comes from the same background that I do, where I've played with open source databases. I've played with the bigger databases, the enterprise databases that I've seen, but not everybody knows it. So first off, the gotcha with Postgres is how do you even say it? Because you look at this and you're like, PostgreSQL, PostgreSQL, PostgreSQL. So Claire Giordano, who does a lot of their talks about Citus, she has a nice video pinned on her Twitter profile, and she talks about how do you say this? She's even heard people say Postgre, which if you're familiar with some of the foreign languages, I could see where that comes from. How do you say Postgres? You're going to hear me just try to keep it to Postgres, because Azure Cosmos DB for Postgres is still a mouthful. All right. And as Jay has been posting, if you have questions, please post in the chat. I will keep an eye on chat as I'm going through my slides as well.
I'm sorry it's such a mouthful. That's not my decision to be made, but I'll be honest with you. It at least explains what exactly it is.
It does. It does. All the APIs have a mouthful for a name, but you know what? This one in particular actually has a history of being a mouthful. I have that in a couple slides, so you'll see what its old name was. All right. So Postgres, just so you're aware, has been around quite a long time. In 1986, it was at the University of California at Berkeley. They demonstrated it at ACM SIGMOD, which is an academia conference, in '88. In 1994, they added SQL. So prior to SQL, they had their own post query language. They also added a tool called pSQL for their interactive queries. They had some support for some front end for clients that supported TCL. And in 1994, they renamed the product to Postgres 95. Now, if that's something we've seen throughout the years, it's you don't want to put the year in your name. That doesn't tend to age well. They made that realization and they renamed it to PostgreSQL. Now, there's a lot that happened between 1996 and 2022, but because we have only so much room on the slide, and because I just want to get straight to the point, we left out all the other details. Rest assured, it is an open source database that has grown over the years, has all sorts of extensions, and in 2022, Azure Cosmos DB said, hey, we have a new API. It's called Azure Cosmos DB for PostgreSQL, or Postgres. So what is this thing? Well, I like to call it the artist formerly known as Azure Database for PostgreSQL Hyperscale. CJ did have a really long name even then. Now, Azure Database for PostgreSQL is still a thing. They have their flexible server and single server offerings. But the one that we're looking at today, it's the one that was known as Hyperscale. It allows you to work at any scale, from a small, hey, we've got a relational database that maybe we want to just see how this works, to, okay, now let's grow with it. But we'll look at non-distributed into distributed with minimal friction. I have a point when we do our sizing on our resource of how to do this with even less friction for scaling purposes. This allows you to what we call shard data across multiple nodes. I'll explain shards, I'll explain the nodes. But think of it as you have all this data for all these clients, perhaps, which is what we're going to talk about. How do we break it up so the client's data is separated in different shards? And so that when I query, I'm only querying that portion of the data and not the entire data set. The Azure Cosmos DB for PostgreSQL is powered by a Postgres extension known as Citus. If you do a search online for Citus, make sure you include the term Postgres with it. Otherwise, your search engine might be like, don't you mean citrus? No. We mean Citus. Citus is what allows us to do this distributed data approach. Now, what is Citus? So Citus is the open source Postgres extension. It is distributed across multiple nodes. It allows you to distribute data across multiple nodes, and it allows your parallel processing of queries, among many other things. There's a link to the GitHub repo. Jay, did you put those links that I sent you earlier in the show notes as well? Yeah, awesome.
I sure did. They are all in if you go to the YouTube description for the video that I posted in the chat earlier, you should be able to find all those links.
Awesome. And I have a lot of links that I sent to Jay earlier. So rest assured, if you're like, oh, there's a link on that slide, we've got it covered. All right, so why Citus? Why not just let's stay with Postgres? Well, after a while, you may outgrow the limitations of a Postgres server. So Citus is there to help you to grow past that single node. It also allows you to stay within that Postgres environment and use the other extensions as well. So today's demo, I'm going to go through their multi-tenant demo. And with that multi-tenant demo, I'm also going to show the Postgres extension. Why? Because latitude, longitude, and more so you can see how to add extensions and remove extensions. All right. So what are the features? And this goes back to the question that Jose asked earlier about, is a document DB under the covers or is it tables? These are tabular. So each node that we'll talk about, and we'll show what nodes are here shortly, but each of those is a standalone Postgres server. You have SQL, you have relational data right under the covers there. They're all Postgres. We'll have two different types of nodes. We'll talk about those, but just know that it's all Postgres. Again, this allows you to do distributed data, but the key thing with Azure Cosmos DB for Postgres is that it is fully managed and resilient. Fully managed means that server administration and making sure that you have servers to scale to, that's handled for you by Azure Cosmos DB. You don't need to worry about it. Now, I guess let me clarify that. So this Citus, going back 2 slides, is the open source Postgres extension. If you want to play with or grow your own Postgres database, and you want to host it, and then you want to do Citus for your growth and for distributed data, you can do that. And the Citus website is awesome for explaining how you get started and such. But my presentation is going to focus on the managed service offering, which is Azure Cosmos DB for Postgres. It supports high availability, read replicas, backups. It has a rebalancer for managing your data, keeping it balanced. We'll talk about the rebalancer. We'll point out high availability. I'm not getting into read replicas or backups, but I have a link to show you more about that. What's nice about Azure Cosmos DB for Postgres, not only is it the Azure Cosmos DB side, but it is also the Postgres side. So the latest Postgres features. You'll see some of the documentation shows Postgres 14, Postgres 15 is supported. So the newer version is actually out there. And there's so much more that you can do with Azure Cosmos DB for Postgres. So the key use cases, let's talk about those. There are 3 key use cases to know for this. So multi-tenant applications, real-time dashboards, and time series data are the key uses that you'll see. I do include links for the multi-tenant and the real-time dashboards, so you can see how to go through that. But know that when it comes to this, so for multi-tenant, the demo we're going to look at is their ad analytics, specifically we have multiple advertisers who want to track their campaigns. They want to track their clicks and the impressions for those. And then we'll also take a look at how do we include geo involved with that, based off of an IP address and some magic that they did there. Okay. So you hear the term shards. When I mention shards, think partial tables. So when you're distributing your data, you're taking a full table and you're splitting it up into smaller pieces or shards. They are split by a distribution column. Or you might hear the term sometimes shard key or partition key. These are terms that you hear in the other APIs. The distribution column is what you'll hear in the Postgres side of things. This allows you to say something like, in the demo we'll see, where we want it so that a company who wants to look at their ads and their the campaigns, the impressions and the clicks, we're going to store all that data on the same node. All the shards for that will be on the same node. Now, shards, again, are partial tables. So going back to Jose's question, under the covers, standalone Postgres server, all these things under the covers that you see are as tables are stored as tables. So it is tabular data. The shards themselves are going to be stored on at least one node. I say at least one node because it depends on if you have a setup of a single node or multiple nodes. I will cover that. But shards for multiple tables can all live on the same node. That is a term that you'll hear called co-location. I'm not going to go too deep into the theory of all this, but I do have links. So there's a Microsoft Learn path that came out at the same time as Azure Cosmos DB for Postgres was announced. And so that Learn path will be able to take you through more details on these. Okay, we have shards and now we have nodes. So nodes, these are the things where the shards live. Nodes and shards, to be clear, are not the same thing. So nodes, we have the coordinator node, and then we have worker nodes. The coordinator node, this is the thing that knows where all those shards live. So when the shards are split up, when I do illustrations of shards in other places, I actually show data. But when I'm not showing the data, in this case, I'm just showing the nodes themselves. I can explain it a little bit further. So for example, we're going to look at companies, and we're going to narrow it down to a single company. That company's data is all going to be grouped together by that company ID. It's going to be what's called co-located, and they're all going to live on the same node. The coordinator node knows where the shards live. So those shards could be on worker nodes, and they are sometimes on coordinator nodes as well. We've got that case that I'm going to show you. Sometimes coordinator nodes do not have those shards either. And it all depends on the approach that you take to spinning up your cluster. The cluster is your collection of your coordinator node and your worker nodes. So coordinator node knows where the shards are, and it will only engage the worker nodes and the coordinator node, if applicable, if they're needed for the query. So the coordinator is responsible for identifying which of the nodes have the shards for a particular query. So we're going to look for company 5. Coordinator node goes, okay, which of my nodes has company 5's details? It's going to be a worker node. And on that worker node, it's going to take a look and see, okay, give me all the details for that. Only that worker node gets engaged, not the entire data set, not all of the shards. Only the worker nodes that have the shards related to the company that we're looking at. Okay. Now, when we get into distributing our data, something to note, that got misplaced. So in our regular data, relational data, we talk about foreign keys and primary keys. That's going to change with the distributed environment. And so we'll come back to this slide when I actually talk through local reference and distributed tables. But first things first, how do you create an Azure Cosmos DB for Postgres account? Glad you asked. I'm going to show you two different ways. Now, I'm not going into the portal. For the sake of time, I have a bunch of screenshots talking through it, but I also want to point out some of the gotchas that I discovered while going through these. So first of all, if you didn't know about this, you can try Azure Cosmos DB for free. That's right, free, as in no credit cards, as in try it. Check out the link that was posted below here. So you can use Azure Cosmos DB. Did I mention what's that cost there, Jay? How much?
It's free. You know, not a lot of free lunches in life, but here's one for you. Give it a shot, everybody.
Absolutely. Absolutely. So you'll give it a Microsoft account or GitHub account. Now, if you already have an Azure account, that's fine. Just know that if you do sign up for this free account, that it's going to create its own sandbox environment. What does that mean? That means that you'll look for it in your own resources and you can't find it. That's because it has its own directory. So in the upper right corner, when you go into your Azure portal and select your profile, you'll have to go to switch directory and point it at your trial. But I'm not going to show that right now. I do want to show you, however, that when you go through this process, you'll tell it to create your Azure Cosmos DB for Postgres. Then it's going to ask you, can it actually do this? So it does ask for consent for the trial. I already have an account, so it already was asking me for consent with my Azure account. And then when I said, sure, you can do this, notice it'll create a sandbox trial. So the sandbox trial means that it is in its own directory in Azure. It is not tied to your subscription. And then other thing to note with this is, let me grab my handy dandy laser pointer. So there's this message here about to get started with your free trial, you must change your password here. The wording on there might seem weird. That's specifically change your Postgres server password here. Going through the free trial, this approach, this is when you set it after you provision the sandbox. Now, you might be like, you know, free trial, I think I'm ready to play with it on my Azure account without the free trial. Then, okay, create an Azure Cosmos DB resource. You'll see the Azure Cosmos DB for Postgres API option, so you'll tell that to create. When you tell it to create, then you're going to have some details to enter. With these details, the things to pay close attention to, I mean, there's your standard resource group. Then you have the cluster name. So this is for your account level. If you're familiar with Azure Cosmos DB in the other APIs, think of this as at the account level. Your location. We'll come back to scale here in a minute. PostgreSQL version, I've selected 15. I've also worked with this on 14, so I can tell you that the things that you see in 14 should still work. There's Citus is the admin username. It is a hard-coded username, so just be aware of that. And then the password you can enter in there. Now I said we'll come back to scale. That's because scale puts us in a different perspective. So we have, by default, one node, no high availability, 2 vCores, and 8 gigabytes of RAM. That is gigabytes as in like base 2, not gigabytes base 10. That one took a little bit for me to have to explain, so just so you're aware on that. This is the minimal for what's known as a single node setup. Your trial will take you through a single node setup. The free trial does not allow you to go into scaling to multiple nodes, so be aware of that. However, if you're going outside of that try Cosmos free, then this is what you'll see. So when you go to create your cluster and go into scale, so this is what you're going to see. By default, it shows a coordinator and a worker as one node. That means those responsibilities are shared on one node. We have the single node, 2 vCores, 8 gigabytes of RAM, and 128 gigabytes of storage. That is for the nodes. Notice on the screen there's nodes, and then it goes straight to high availability. The reason why I'm pointing this out is because it's about to change when we increase our nodes. So if I increase my nodes, now we're looking at 2 nodes. Notice now the coordinator and the workers are separated. It's 4 vCores at 32 gigabytes of RAM, 512 gigabytes of storage. And now we have a coordinator node that has its compute and storage separate from this section here, nodes, which applies to the worker nodes. So your worker nodes and your coordinator node can be managed separately for compute and storage. But notice when we go into 2 that their minimal values change. So it's 2 nodes, 4 vCores, 32 gigabytes, versus the other one, which was like 16 gigabytes, and 512 gigabytes for storage versus the 128 gigabytes. So those differences, the reason why I'm pointing it out now is because this can make a difference for when you go to scale. If you start your single node with your minimal requirements and then want to scale to the multiple nodes, there's going to be a restart required. There will be downtime when you do that scale. However, if you create the single node with these minimal values, then there will not be a restart required. I've done this many times as I've been working with this for quite a while now, and so I can assure you that the setting you want, if you're working with a single node and you want to be able to scale out with minimal downtime, minimal friction, is go with a single node with 4 vCores with your 16 gigabytes of RAM and 512 gigabytes of storage. All right. And then when you go to create your cluster, do not worry about setting the firewall rules as part of that. And the reason why I say that is because I've run into a bug with this, where I set the firewall rules and they don't always carry over. And so I just wait until after the account's been provisioned, then I'll add the firewall rules. All right, so we've figured out how to create the account. The next thing is going to be creating those firewall rules. I'm going to go to the next slide so you can see. So once your account or your cluster is provisioned, that's when we go into the networking section. Under networking, you'll scroll down a little bit into where it says public access. Now with public access, this checkbox that I have highlighted here, this is going to allow us to connect to our server from Azure Cloud Shell. Below this option, you can then also tell it to allow your IP address and allow some other ranges in. This allow public access, though, is enough to deal with it in Cloud Shell. So what does that look like? Well, let me show another slide before we get too carried away. So PSQL, we mentioned PSQL is the interactive window. PSQL is what allows you to run those queries. And these are some of the shortcuts you may see me run. These are not the exhaustive list, but just the ones that I tend to type a lot in demos. So if I want to list all my tables, I'm doing /dt. More details. So these commands you'll see plus will show more details. It gets into the technical undercoverings sometimes. /dx will show your extensions. If you want to know more, /?. And of course, the important thing is how do you get out of your tools? /q for exiting PSQL. All right, before I get into the demo, I do want to show you the way that demo is laid out in terms of the ERD. So we're going to do a multi-tenant ads demo, and this is, you'll see it in the multi-tenant documentation in the Azure Cosmos DB side. You'll also see it in the Citus documentation. I think the Azure Cosmos DB side takes a more straightforward approach to it, but then I also add PostgIS into it. All right, so this is pre-distribution. Let me see, where's my Zoom? So you can see that we're working with things like the companies, and every company, there's a campaign. So a campaign will have a company. The ads go to the campaigns. These are your standard foreign keys in a relational world. So ad ID goes to ads, and ad ID goes to impressions. From a relational standpoint, all looks fine and dandy. It makes sense. From a distributed standpoint, that's where it's going to be a little more confusing. And the reason for that, let me zoom out, is because you don't have a field here that's common across the fields that would be able to keep them all together. If you remember, I mentioned that we want to store all the company's information together. So we're going to add the company ID as part of our primary keys in our distributed. So the difference, let me go back, pre-distribution, this is what you would start out with. You're like, okay, I just need a simple application that I don't need to worry about scaling right now. This is what this looks like. But when it comes to distributing, and the Microsoft learning path for Azure Cosmos DB for PostgreSQL has a module that talks about how do you choose a distribution column and what makes sense and the considerations that you have to have. This is how we end up going to, we add the company ID as the primary key with the ID field for that table. Then the other thing to note with these that I don't really have demonstrated here because it gets really messy is that your company ID is also included as part of your foreign key. So your foreign key for impressions over to ads is going to be ad ID and company ID. Your foreign key for clicks to ads is going to be ad ID and company ID, and so on. So distribution adds a little bit of complexity in terms of your structure. You might have to add another field to make that happen. But this then allows you to say, okay, all of the campaigns, all of the ads, all of the clicks, all of the impressions, and all the company records for a particular company will live on the same worker node, which makes it easy then for the coordinator node to go, okay, we want to take a look at the things for company number 5. Which worker node has number 5? That worker node will have all of the shards or all of the partial tables. So it'll have a partial companies table for 5. It'll have a partial campaigns for 5, partial ads for 5, partial clicks for 5, and partial impressions for 5. So these shards, these partial tables, allow us to then focus on querying only the things we need. Now, what happens if we don't include our distribution column or we don't include the company ID in the where clause? Then guess what? The coordinator goes, I don't know who I need to engage. I'm just going to engage all of the nodes that have shards. So having a distribution column, knowing which shard it needs to go to, that will reap in benefits for you. All right. So now how do you do connection strings in here? Just like many of the other Azure Cosmos DB things, you're going to the left, look under settings. You're going to look for connection strings. Now for the demo that I walk through and what they do in the Learn modules, they use PSQL. For the sake of time, I'm not going to walk through the Cloud Shell and demo it just because it gets to be copy paste, hide the password kind of deals. But just so you're aware, you grab the PSQL connection string. These connection strings do not have your password in there. They will have a spot for you to change from curly brace your password to enter your password there. So be aware of that. The other thing is with the PSQL one, you could take the password out, just run it with the rest of the connection string, and then it'll prompt for your password. PSQL again is the command line. Actually, I take that back. I do want to show you PSQL. Let me make sure that I can share that with you all. All right.
And everybody, if you're watching, I just wanted to remind you that if you want to present at a future meetup, check out the chat. We've got our user group submission. Just like Sarah, you can represent what you're doing to the rest of the community. So Sarah, I'll let you continue along with your demo.
Cool. And I wasn't planning on showing PSQL, but I'm like, you know what? I'm going to destroy this after anyhow, so you can see my super secret passout 1, 2, 3. All right, so /D, again, this tells me the tables that are out there. I have some sequence tables out there. I see some views. Say I want to see what companies it looks like. I can do /DT companies. Get that. If I want to see more about that table, I can do /DT plus. You can see it shows who's the owner of the table, the access, the size, the description, and so on. If I wanted to get into the, let's see, who's got a better one for showing that, impressions. I can do /D plus and impressions. There we go. For more on just the table itself. If this looks hard to read, then you could change your output this one doesn't have it easily. But you can see that it talks about the data types. It talks about the default values and things like that. And I'm going to do /Q and quit. And that's it for Azure Cloud Shell. Now, the reason why I don't want to show more of Cloud Shell is because demoing in text can be a little tricky. And also, I want to show you that Azure Cosmos DB for PostgreSQL means that you don't need the Azure Cosmos DB SDK for your development. You're going to use the Postgres drivers that are already out there for your language. The Citus docs, if I remember right, show Ruby and Django, which is Python. But I have been playing with it with NPSQL and PGSQL. The .NET driver as well works. But today, when I connect to the database, I will show you pgadmin 4. So you can see all the queries that we need are going to be in this tool. We'll come back to this tool in a little bit. Okay, so Azure Cloud Shell and pSQL, you could definitely run these from a command line. The tutorials will walk you through that as well. Some things to note with that. So shell.azure.com will get you straight into Azure Cloud Shell, but you could also go directly to the portal. So you saw my bash was at the bottom. That's because I did this approach with the shortcut through the top of the portal. What's nice about that is then I can see my SQL connection string up at the top and copy that and paste it in. Not have to worry about switching between tabs. All right, so when we create the tables in pSQL, you'll create the companies first. Then after you create them, then you can start creating the tables. Each of those tables will have an ID, and a company ID is their primary key. And a company ID field gets included in the foreign key. These are for distribution. Now, do you need to distribute data first, or can you bring in the data and then distribute? The order's fine just starting out when you're dealing with small stuff. But if you distribute first, then when you load the data, it goes directly to the shards it needs to. So that's what happens with that. The tables we'll create are campaigns, ads, clicks, and impressions. All right. Now, when we distribute the data, there are 3 types of data to know. There's local, reference, and distributed. So local data lives on the coordinator node. It is strictly there for, you've got your metadata and you have your local data. Local data, think of it like user logins and things that they only need to be in one spot. They don't need to be accessed across the other nodes. So that's where local comes into play. It's one spot. Reference, so think of reference tables as it's a copy of a table on each of the nodes. And then distributed, that's where you get into the shards. That's where you get into the partial tables. And it's based on a column across multiple nodes. So then why would you do this? You need to know which tables are where in terms of organizing, in terms of size, in terms of how do you access them. The demo, we'll talk about distributed and reference. We won't show local, but just so you're aware that local are a thing. Now, a few slides back, we were talking about foreign keys when it comes to the foreign keys. So let me go back to the slides. And not that one. I'm going to go back to the slide where we're talking about the foreign keys. That's back here. So when we talk about tables, so foreign keys in relationships, they work when they're between 2 local tables. The coordinator has both tables. They can see it just fine. Reference tables, if there's relationships between 2 reference tables, that's fine as well, especially if you think about it where they're on the same node, it works nicely. When you're working between reference tables and local tables, that relationship works okay. And if you're working with 2 co-located distributed tables with a shared key, so all of our tables are going to have a company ID with the exception of companies. That's the field is ID, which represents the same object. So we'll have relationships between those tables that work just fine. And if you're going from a distributed table to a reference table, that's okay as well. But from a reference table to a distributed table, that doesn't work so well. And if you think about that, the distributed table, those are your shards, those are your partial data. It doesn't necessarily know the relationships between a reference and a distributed because it could be distributed across and it just can't make those connections. Now, that said, they are working on supporting relationships. So this was what I knew when we were working with Postgres 14. If it has changed, I wouldn't be surprised. Okay. Right, so we get our connection string, we connect to Azure Cloud Shell. Before we distribute the data, some things to note is there are going to be some limitations when you're in that distributed state. So we saw that the foreign keys and primary keys, those relationships, there are some gotchas. If you're working with like correlated subqueries or recursive CTEs, table samples, select for updates, and grouping sets, those won't work so well. So if you have to deal with those, you might not want to deal with those in a distributed environment. If so, you have to change the way you handle things. So for the demo, you can load the sample data from the Citus website. We use a command called /copy in pSQL to load those from CSVs. And I'm going to bring over my pgadmin because I do have those commands in my pgadmin. So pgadmin is, again, Postgres tools. I'm using a Postgres tool to talk to my Azure Cosmos DB for Postgres. I'm not using Azure Data Studio or any of the other Microsoft UIs. There is a Postgres extension for Visual Studio Code. I haven't had good luck with it yet, but your mileage may vary. pgadmin works fine for running our queries. You know that I'm connected because it's Citus at Citus, and this is my Azure Cosmos DB Global UG. Here's those create scripts we were talking about. Scroll past those. This is where we get into like the sharding. So in the demo, you create the tables and then with the foreign keys, and then we do the sharding. Notice here it's create distributed table. Now, if you have data already in place, then you do something called create _ distributed _ table _ concurrently. Again, to minimize your friction as you're distributing your data. All right, so this is what I was talking about with you download the CSVs. And in my particular thing, I say do this in Bash because I tend to copy and paste from my scripts and put them where I need to. So this will get the CSV files for company CSV, campaigns CSV, add CSV, click CSV, impression CSV, and GeoIP CSV. Once you download those, then the next thing is to copy them from the CSV to these tables. So copy the table from the CSV name with CSV. This will copy those into your thing. So load the data. And then we can do things like query the data. So we are working with company 5. And if I run that, and let me see if it's going to let me, there we go. I don't know that it's going to let me change my output size, but it talks about the company name is the Love Pirates. I might have changed the data to make it Valentine's Day themed. So if you go through the data and you're like, I don't have that value, it's because I was trying to be Valentine-y. All right, so we want to look at the campaigns for that company. Notice these are pretty standard relational data queries. This selects where. And then you can see things like we're looking at chocolate-covered strawberries and bacon roses and peanut butter cookies, marshmallow hearts, candy hearts, heart cakes. Sorry, guys, I couldn't help it. Valentine's Day, it called. All right. Notice here, I'm doing a query where it's like the name, the cost model, state, monthly budget. This all looks like it's a regular SQL query, which it is. This is still your relational SQL, I promise you. The key thing here is this where company ID equals 5. When you distribute your data, breaking it into those partial tables, you need a hint to your coordinator to know which nodes to engage. And so because it knows the company ID is its distribution column, that's how it knows which worker nodes to engage. Talk about like doubling budgets, so standard updates. We have some standard campaigns, just so you can see what happens if I run the windowing. Oh, by the way, if you're familiar with like SQL Server and you're not familiar with Postgres, pgadmin, you can still highlight the query and run it, and it'll run what you have selected. So I can see, here's aggregates. I have a GeoIPs. So we'll talk about GeoIPs here in a little bit. All right, so we showed loading the data, copying it, querying it. Again, you can use the aggregates, you can use your ranks, you can do all that in here. But that where clause, again, is what's key for the coordinator node to which worker nodes to engage. The reference table demo, so the quick start, we'll show you there's this GeoIPs table. What that allows us to do with a reference table is that now it's going to be on all of the worker nodes. Each of the worker nodes will have their own copy of this GeoIPs reference table. This is going to then allow us to find the GeoIPs for the people who've clicked on certain campaigns. So let's go back here. So this is the query that we're seeing. And so you'll see that it comes back. There's a big int, a timestamp, and then a point. Well, a point is an okay data type, but what if you want the latitude and longitude pulled out separately? This is where the extension PostGIS can help. PostGIS. But we'll talk about that in a little bit. If you're not sure if your data is distributed, there's the select star from Citus tables. And I don't have that in here, so we'll just type it, select star from Citus tables. And you know what? Let me do that lowercase so you can see from Citus underscore tables and run it. So you can see that I do the select froms, wheres, and the keywords as capital. It's just my particular approach to things. But you can see that we have distributed tables and our GeoIPs is a reference table. So I've done the creates because I knew we would be short on time. That way you can see the structure. You can also see things like the table size, and you can see who owns the table. You can see the number of shards.
We've got about maybe 8 minutes. If you want to go over a couple minutes, we can, but we may lose our reactor stream. But we've got about 8 minutes left.
Yep. All right. So you can add more worker nodes. Again, I pointed out the minimal requirements needed. You cannot do this on the free trial, though. You can do this if you have your own Azure account and have done the Azure Cosmos DB or Postgres cluster. You go to scale, and you tell it the number of nodes, and then you can, again, configure your coordinator, compute, and storage separately. As they're provisioning, this is what you'll see in your Azure portal. You'll see the coordinator, and then you'll see the workers. The coordinator exists all the time. The workers, these are the ones that we added. So now we're adding 2 workers. They'll be in provisioning. They eventually do hit available. Once they hit available, then you'll be able to see, okay, so I already loaded my data in a single node. Now I have 2 worker nodes. What does this look like? When I do this, I will admit I'm pretty impatient. So I went to the shard rebalancer and I'm like, oh, look, there's 2 gigabytes there on one of the nodes and 0 gigabytes others. And rebalancing is not recommended. This doesn't make sense. Hold up. Well, that's because the nodes are still coming online. So you may run into that. And then you may see something where it's on one of the other nodes and it's still not on that. And it still says it's not recommended. Rest assured, as it's bringing nodes up, it'll take it a little bit. Then it'll tell you rebalancing is not recommended at this time. And you're like, but wait a minute, I just scaled out and I just have my data on my coordinator node. How do I get it to the worker nodes? Patience. Once you're patient enough, it will tell you rebalancing is recommended. The rebalancer is what will then distribute your data across the nodes in a hopefully more balanced way. I say it hopefully because there are a couple ways you can try rebalancing. If you have enough data and you rebalance one way, it's fine. If you rebalance another, that's fine. Sometimes not so much. In my screenshots, I've got some not so mushes. So this view rebalancer execution plans will tell you the 2 different ones. It is through disk and through shard size. And so there are 2 different ways that you can handle that. Now, you can also trigger the rebalancer using select rebalance table shards. So rebalance underscore table underscore shards plus the table name. This is a link for the documentation for Microsoft Learn. And when I went with this approach, it seemed pretty standard. However, we ran into an issue. So as you do the rebalancer, you can see things such as where is your data moving? So it's going from one to another. So it's going from, in this case, it's replicating over to the worker nodes, the W0, W1, those are worker nodes. The C dot, that's your coordinator node. So it's moving some shards off the coordinator. Sometimes you can see the movement down below, sometimes you don't. Even after rebalancing, though, you might want to run the rebalancer again just to confirm. In this case, it was still saying rebalancing is recommended. So then I did view the execution plan. Notice in here, I have the option of rebalancing by disk size. So when I do that, notice it's going to impact one shard. That shard apparently is a larger shard that needs to change and rebalance. So it had it use that rebalancing, and then it went to rebalancing is not recommended. All right, some helpful Postgres extensions. So being in the Postgres world with Azure Cosmos DB for Postgres, you'll see things like PostGIS, which is good for your geography and geometry. pgcron, so scheduling jobs. pgdump, making sure you can take backups. There's a PG Azure Storage. You can work with your Azure Storage. If you want to know which extensions are supported, that's PG_available_extensions, and then which ones are pre-installed or under PG_extension. All right, Postgres demo. So you added extension by doing create_extension, and then a quick demo. I know we're running really short, but we're going to get through this real quick. So Postgres allows me to go and pull my X and my Y out of my point. And if I run that, you can now see my latitude and my longitude are separated thanks to the PostGIS extension in Postgres. All right. Now, with extensions and nodes, I had my PostGIS installed on my single node, and when I scale it out and try to run that query, I got an error that said it couldn't find public.geometry. I was like, what in the world? Oh, I installed the Postgres on the coordinator node, but those two new worker nodes didn't have it. In order to add that to those, I had to drop the extension, and then I had to recreate the extension. So drop extension, drop _extension, and create _extension. Now, when it comes to tools, pSQL, pgbench for benchmarking, use Postgres drivers for your language of choice. Again, npgsql for .NET is what I would use. You're seeing me demo pgadmin, talking directly to the database that way as well. And link to one of my favorite resources, the Azure Cosmos DB for Postgres Learn Training Path on Microsoft Learn. 4 different modules: data modeling, ingesting and querying, extending. By extending, that's using the extensions, not creating your own extensions. Then managing the performance and availability. And that is Azure Cosmos DB for Postgres in a nutshell. If you have any questions, feel free to hit me up on Twitter as Saduki or connect with me on LinkedIn at /in/Saduki.
Thank you so much, Sarah. You got it right there on under the wire. And I think what we're going to do is, Albina, if you want to come back, and we'll go ahead and close it out. First of all, I just want to say, Sarah, thank you so much for being part of this today. We've shared where people on the internet can get in touch with you if they want to continue to follow up with this conversation. We had some great questions. Unfortunately, we couldn't get to all of them in our time, but our time is just about over. And Albina, why don't you tell us what people can expect from the Reactor moving ahead?
Yeah, that was a great session, Sarah. I really enjoyed it. I always look forward to this session with Jay. So we have a couple of series coming up with the Microsoft Reactor. One of them is Launch Your Career that you're just looking at right now at the screen. So if you're exploring in your career, or if you want to get into data scientist, AI engineer, web developer, cybersecurity engineer, if you want to learn more about this potential technical jobs, please join us. They will be going on Mondays and through June. So if you can come, you can sign up. We have the list there. So yeah, welcome.
Wonderful. Well, thank you everybody so much. Oh, Sarah, you got it up. Thank you so much. There's the Launch Your Career page. You can go there and use that. All right. So I think it's time for us to say goodbye. We'll be back next month. We've got something planned on cost optimization with someone from our global Black Belt team. I think it'll be great. But until then, Sarah, thank you so much. Albina, it's always great to see you, and I know I'll see you again next month.
Yes.
But until then, everybody, have a great rest of your Valentine's Day. I hope you get a big old kiss. And until next time, we will see you. Bye-bye.
Valentine's.
Yay.
Bye.